Hello everyone, I am Nabil and today I'm going to talk about a project that I've been working on this semester where I try to study the process of switching between driving and non-driving tasks in autonomous vehicles. For autonomous vehicles, it is very important to have an elegant process to switch from autonomous to manual driving. For that, we need to understand the process of switching between driving and non-driving tasks. Dr. Jensen and his team proposed a 10-stage model to explain this process, but the problem is we still don't know much details about those stages, like where the driver is looking or how long the driver is taking in each stage of this process. We'll try to address that problem in this study, and our goal is to analyze drivers' visual focus in autonomous and manual driving mode and also during the transition period. We will also provide data for understanding the 10-stage model of transitioning between driving and non-driving tasks. In this project, we hypothesize that people will spend more time looking at the road during manual driving mode compared to autonomous driving mode. And we also hypothesize that people will go through all 10 stages while switching between driving and non-driving tasks. To test this hypothesis, we will conduct an experiment where the participant will operate a simulated vehicle. The vehicle will alternate between autonomous and manual driving mode, and the participant will be asked to engage in a secondary task during the autonomous driving mode. The secondary task will be a simplified version of the 20 questions game, where the participant will ask some questions and try to guess an item based on the answers. To simplify this task, the participant will be given a set of objects to choose from and also the corresponding questions to ask. For the secondary task, participant will be interacting with a voice assistant. We use Cortana for this task, and we will be collecting eye tracking data and also keeping a log of all the interactions between the participant and Cortana. You can see the experiment setup here. You can see the eye tracker, the Cortana interface, and area of interest, which will be used to determine whether the participant is looking at the road or not. Several researchers have explored the relationship between different kind of secondary tasks and driving performance. Dr. Simmons and his team found that non-driving tasks like texting that requires driver's visual attention affects the driving performance more compared to some other tasks like talking on the phone, which does not require the driver to take their eyes off the road. This result is in accordance with Wickens multiple resource theory, which states that while multitasking, if both tasks uses same resources, then they will affect each other more. So, for example, if someone is texting and watching a movie, then those two tasks will interfere with each other more compared to if he was texting and listening to music, because texting and watching movie both requires visual resources. So these studies show that there is a correlation between visual focus and driving performance in different driving conditions, and also the non-driving tasks affect the driving performance even if the driver doesn't need to take their eyes off the road for performing the secondary task. Poorly implemented speech interface can also negatively impact driving performance, and driver's decision to engage in a non-driving task also depends on the driving conditions. So the driver is more likely to engage in a secondary task if they are not turning or changing lanes. People also spend more time looking away from the road as the level of autonomy increases. So, for example, people will spend more time looking away from the road if adaptive cruise control is on. Here is a short demonstration of the experiment. At first, the driver is driving in the manual mode, and once the autonomous mode started, the participant started to engage in the secondary task. Once the participant successfully guessed the item, the role of the driver and the Cortana will interchange. So after that, the Cortana will ask the questions, and based on the answer, will try to guess the item.
Autonomous mode started.
Hey Cortana, open secondary task.
New game. You can start.
Is it in the kitchen?
Yes.
Is it related to eating?
No.
Food processing?
No.
Utility?
Yes.
Does it have door?
Yes.
Is it refrigerator?
Correct. Now you guess an item from the list and answer only yes or no. Is it in a kitchen?
No.
Living room?
Yes.
Entertainment?
No. During the experiment, we collected eye tracking data to analyze the glances of the driver in different driving mode and during the transition period between them. Then we identified all the time periods for all those driving modes and calculated the percentage of time the driver spent looking at the road. We found that the driver was looking at the road for 49% of time during the autonomous driving mode and 91% of time during the manual driving mode, which supports our hypothesis 1. To build on this work, we can implement the experiment setup using a more advanced driving simulator like the mini-sim shown in this picture, which will allow us to collect driving performance data in different driving conditions. We can also analyze the driver's performance in the secondary task, and by using these sets of data, we can explore the driver's response in different driving modes and better understand the process of switching between driving and non-driving tasks in autonomous vehicles. These are the references for all the studies I mentioned in my presentation. I'd like to thank Dr. Kuhn, Dr. Mills, and all the students of this course for their feedback on my project throughout the semester. If you have any question, feel free to leave a comment and I'll try to answer that. Thank you.